Hello friends, today we are going to discuss chemical bonding, class 11 chemical bond chapter number 4. Now the question is, what is chemical bond? Most of the elements exist as a molecule which are cluster of atoms. How do atoms combine to form molecules and why do atoms form bonds? These type of doubts are going to discuss in this chapter. So first of all, you must know molecule is more stable than atom. Now question is, why molecules are more stable than individual atom? The reason behind that is the molecules are more stable because they have lower energy. Because they have lower energy in comparison to individual atoms. Now, what is chemical bond? You might have heard lots of definition about the chemical bond, a force of attraction between the two atoms which attain stability. Yeah, that definition is 110% right, but here as in the manner of writing, the force that acts between two or more atoms to hold them together as a stable molecule. It is the union of two or more atoms involving redistributions of electron among them. This process accompanied by decrease in energy. Decrease in energy is directly proportional to the strength of bond. Therefore, molecules are more stable than atoms. Now, the question was, why molecules are more stable than atoms? These all the questions has been answered according to chemical bond. As we know very well that when two atoms are held them together to make a molecule, that time the molecule has an extra stability. What is molecule? It is the union of two or more than two atoms. It can be involved by the redistributions of electrons among them. Why they redistribute electrons? When their energy has decreased, then only this probability is possible. The distributions of electrons is only possible when there is a decrease in energy, and as the decrease in energy happens, the bond becomes more strong and the molecule is formed. So who had given this concept? Earlier you might have heard about Newton's octaves law in the periodic table. So Kossel and Lewis has tried to give its approach towards the chemical bonding. He thought that electronic configuration of inert gas elements are much more stable because they do not participate in the chemical reaction. So according to Kossel and Lewis, any elements try to attain the electronic configurations like inert gas because at that time it was believed that inert gases do not take part in the chemical reaction. So any element will try to attain stable electronic configuration, that is inert gas configuration. Elements can either exchange electron or it can share the electrons. This basis was from the Newton's octaves rule. You can see here, this is a cube in which there are 8 atoms, and in this cube there are only 4 atoms. So when there are 4 atoms, we can say that it is an incomplete octet because all the corners do not occupy the number of atoms. And here in a cube we can see that all the 8 corners had occupied one atom, so we can say that it is a stable electronic configuration. Now let me show you that if we talk about an atom has more than one cell, 2 cell, 3, 4, 5. According to the elements, it depends. So if an atom has different number of cells, so now what we will call to these cells? There are 2 types of cells. The last orbit cell is known as valence cell, and before that the cells except the valence cell, all the cell will be known as kernel cell. As you can see here in the diagrams, it is represented at the bottom. You can see here atom has distributed into the 2 parts: kernel cell, that is all inner cell which are non-reactive, and valence cell which are outermost cell where the electrons participate in bonding, they are reactive. So these are the 2 types of cell in an atom. Kossel and Lewis explained this by the example of alkali metals and halogens. They said that alkali metals and halogens can be separated by all inert gases. The reason behind that is alkali metals lose one electron to attain inert gas configuration, and halogens accept one electron to attain inert gas configuration. So alkali metals can easily lose 1 electrons and halogens can easily gain 1 electrons. So both of these elements attain the inert electronic configuration. Now the question comes in our mind, what are the causes of chemical combination? If we talk about the causes of chemical combination, the most important thing, that is tendency to acquire minimum energy. Why any elements will acquire minimum energy? So when two atoms approach to each other, let us take an example of H2. When one hydrogen atoms approach to the another hydrogen atom, that time the first atom nucleus attracts the second atom's electron toward itself and vice versa. Means, what I mean to say is that first atom's nucleus and another atom's electrons are also being attracted. So according to the quantum theory, when two atoms of elements approach each other, then there will be force of attractions as well as force of repulsions. Now question is, so how force of repulsion and force of attraction? As you know very well, similar charge repel each other and dissimilar charge attract each other. So now the first hydrogen nucleus will attract the first electrons, and similarly second hydrogen atom's nucleus will attract the second hydrogen atom electron towards the nucleus. Now first atom nucleus approach to the second atom's electrons and try to attract toward itself. Similarly second atom nucleus try to approach the first atom electron towards itself. So now in this case, both the atoms electrons repel to each other and both the atoms nucleus repel to each other. But if we talk about both the atoms nucleus and electrons, they attract each other. So at the minimum distance, when these forces become equal, then there is a formation of equilibrium state, and that time the bond is formed and the atom of the elements get stabilized by the bond formations phenomena by lowering their energy. If the net result is attraction, the total energy of the system molecule decreases and the chemical bond is formed. So we can say attraction is inversely proportional to energy and directly proportional to stability. And while this process the energy is released, so we can say that it is an exothermic process. Now question comes in our mind, that what are the tendency to acquire the noble gas configurations? Atom combines to acquire the noble gas configurations only and only in their outermost cell and with the help of outermost electrons. What are the outermost electrons? Like NS orbit is there, so it can attracted by the S electrons. NP orbital electrons can participate. Even N-1D, whenever we talk about N-1D, so my dear students, metallic bond is formed with the N-1D electrons. So only outermost electron, that is NS, NP and N-1D electrons participate in the bond formation. Inert gas elements do not participate as they have a stable electronic configuration and hence minimum energy. So the stable electronic configuration like 1s2 or NP6 do not participate in chemical bonding. Now let's talk about Lewis octet rule. What is Lewis octet rule? You know very well, every element atom has a tendency to complete its octet except hydrogen. Hydrogen has tendency to complete its duplet. Duplet means 2 electrons. That is helium configuration. To acquire the inert gas configuration, atom loses or gain electrons or share electrons. The tendency of atoms to achieve 8 electrons in the outermost cell is known as Lewis octet rule. As you can see here, H2O molecule. Hydrogen has 6 valence electron and it is being shared by one hydrogen atom. So we can see here the tendency to achieve the octet in this water molecule. Similarly BeCl2, but in the BeCl2 you will see the chlorine attains the octet, but beryllium has only 4 electron in its outermost cell. So now it doesn't obey Lewis octet rule, but many compounds obey. So now question is, what are the exceptions of exceptions of Lewis octet rule. Incomplete octet molecules, that is electron deficient molecules, or we can say hypovalent molecules. Some of the compounds which are stable but they do not have octet in their outermost shell, in the central atom, do not have octet. So now question is, so how is it possible? Especially this occurs in the group number 13, that is third A, like BH3, BF3, AlCl3, BCl3. Hydrides and chlorides of boron and aluminium do not have octet. As you can see in the structure BCl3, boron has only 6 electrons. In BeCl2, beryllium has only 4 electrons. ZnCl2, zinc has only 4 electrons. Trimethyl gallium has only 6 electrons. The question is, so how do these atoms are stable? So since Lewis does not explain about this concept that even the elements are having less number of electrons than octet, but then though they are stable. The reason behind that, if I talk about BH3 or BCl3, so there is a question, so they form dimerizations. So that time boron attains the octet and they get a stability. But although then also BH3 or BCl3 is a stable compound. Why? So group number 13 elements does not have octet in its outermost shell. So now why these compounds are stable? Why these compounds are stable was not explained by Lewis. Now second question is about hypovalent molecules. Means superoctet. One compound which has less number of electrons and another compound had more than 8 electrons. But then though they are stable, like PCl5, SF6, IF7. So these compounds have more than 8 electrons in their outermost shell. So this was also not explained by Lewis octet rule. Now the most important question, pseudo inert gas configurations. Cations of transition elements which contains 18 electrons in their outermost orbit, but then though they participate in chemical reactions. So now question is, except 8, how it has been participate and how they participate in a chemical reaction. This was also not explained by Lewis octet rule. And the last but not the least, odd electron molecules. Some of the compounds have unpaired electrons in their outermost shell, like NO, NO2, ClO2, ClO3, NO molecules. This does not have octet in their outermost shell, but then though they are stable. So these were the limitations of the Lewis octet rule. These were not explained by Lewis. So you can solve this, some questions I'm giving you. You can take a screenshot of this classwork 1 and you can solve these questions. So you have to draw the Lewis dot structure of H2S, SiCl4, BeF2, CO3 2 minus, formic acid HCOH. And here is your DPP1. You can take a screenshot and you can solve this. So that's all for today. Rest we'll discuss in the next lecture. I hope all of you have understood these questions, and in the next lecture we'll discuss also about this DPP, and I hope all of you have enjoyed this lecture. Thank you very much.